Hello students, this video is on dilations, what they are and a couple examples of using them. So first of all, a dilation is a transformation that keeps the shape the same but changes the size. A dilation like blows it up or makes it smaller. So it's a transformation that produces an image that is the same shape but different size. And when that happens, they're called similar. So we have dilations create similar shapes as opposed to congruent shapes. We're going to be talking more about similar and congruent triangles coming up. But right now, you need to know that dilations are not an isometry. Remember, isometry creates things that are the same shape and the same size, creates congruent things. So dilation is not an isometry. Okay, let's take a look at this picture of a dilation and kind of break it down and see what we have. Dilations are made up of two things, right? First, there is a center of dilation, okay? That's this fixed point from which it is either being expanded or contracted from that center of dilation. And then we need to know also for dilations, the second thing is the scale factor or the ratio. And that pretty much just tells you how much bigger is it becoming or how much smaller is it becoming. If this length of the side used to be 6 and now it's 10, I can make a ratio of those two sides. 10 over 6 reduces to 5/3, so the ratio tells us that the large triangle is 5/3 bigger than the small triangle. Okay, and as we look at this, there are a couple of properties that stay the same. First of all, whatever angles you have in the original triangle, when you make it larger, the angle measures are still the same. That angle would be equal. And if you were to have lines that were parallel in your original one, let's say you had a parallel line inside here, then when you blew it up, that line would still be parallel. Parallelism is preserved, is a property that's preserved. Another property that's preserved is collinearity. So if I have, let's say I have this point and this point, and in between them I have another point, and these 3 points together are linear on the same line. If I have 3 points that are on the same line in my original one, then when I blow it up, when I do my dilation, those points are still collinear. They're still in a straight line. Then midpoint is also preserved. If this point is the midpoint of the side, then when it gets bigger, it would still be the midpoint of the side. And orientation stays the same also. So that means that if I had this, if these were in order A to B to C, then when it's blown up, the points are still in order, A prime, B prime, C prime. So orientation means that those letters are facing the same direction, right? Okay, so those are properties that are preserved with dilations. Okay, so what do dilations look like more mathematically? Well, it takes dilation, let's say we just use K for our scale factor. Dilations take the point X, Y, and it multiplies all of the values, both the X and the Y, by whatever the scale factor is, K. So it just takes the numbers and multiplies it. Now, whatever that K value is, whatever that scale factor is that you're multiplying by, is going to tell you how the shape changes. All right, so if the K value, if the scale factor is a number that's greater than 1, that means that you're going to enlarge it, it's going to get bigger. If the K value is a number between 0 and 1, or between -1 and +1, if it's a fraction or a decimal, then it's going to be reduced. It's going to get smaller. It's going to shrink if it's less than 1. And good. So now if it was equal to 1, what would happen? Well, if the K value was equal to 1, multiplying by 1 just gives you the same number, right? So it would be the exact same size. Okay, so here's an example. Let's just do a dilation of 3/4 to this point, 1220. Okay, so the point 1220 I am going to do the transformation, this arrow. So we multiply each of the numbers by 3/4. And that gives us our solution. 3/4 of 12 is 9. And 3/4 of 20 is 15. Okay, lastly, let's see if we can graph the image of quadrilateral EFGD after a dilation of scale factor 3. And that scale factor is centered at the origin. So what we have to do then is take this entire shape and we're going to dilate it by 3, which means pretty much we're going to multiply it by 3. So first, let's figure out where all these points are. And now we just need to take each of these points and multiply both the x value and the y value by 3. The new point will be E prime. We use this prime to represent the image and the letter itself to represent the original. So -3 times 3 is 9, and -9, and 3 times 3 is 9. Great. So multiplying each of these numbers by 3 gives us our new shape after the dilation. So now let's take each of these points and graph them. So E prime is -9, 9, 6, 9, 6, 0, -9, -9. Okay, so let's go ahead and connect those. Great, there's our shape. And that is the lesson on dilations.